Hey guys, hi, welcome back. So in this video, we will solve the questions of Jest, and these questions are of atomic and molecular physics. All right, so let's see the first question here. So the first question is from Jest 2012. Okay, so here the first question is the binding energy of the hydrogen atom when electron is bound to proton. Then the binding energy is 13.6 electron volt, and the binding energy of positronium, that means when electron is bound to positron, then what will be the binding energy? So here the binding energy, okay, of hydrogen atom is given. So we know in hydrogen atom, electron is bound to proton. So you will have to find the binding energy of the positronium. That means when electron is bound to proton. So this is quite simple. We know the formula of binding energy. Okay, we can write in terms of the reduced mass. Okay, it's minus 13.6, right? Divided by n square. This is mu by me. This is the reduced mass. This is the mass of the electron. So if you see here, you can see from this formula, binding energy is directly proportional to what? It is directly proportional to the reduced mass. Okay, so reduced mass mu, it is equals to what? Small n2 with the product of the masses and divided by the sum of the mass. Okay, so here electron is bound to positron, right? This is what you are having. So for this you will have what? Me. Okay, again you will have what? Into here what you will write for this case, electron bound to positron. So you will write here so it is Me. Okay, here also you will write Me, because you know positron, it is what? It is an antiparticle of electron. So this is reduced mass for electron bound to positron. All right. So divided by Me plus Me. So which will give you what? This is Me square by 2Me. Ultimately, it is Me by 2. Now you will find for electron bound to proton. Okay. So for that you will write, suppose I'm taking this to be mu1, this I'm considering to be mu2. Okay. So now electron bound to proton. So here you will have what? Me, right? And here you will have mass of proton, MP, and this is Me plus MP. So we know mass of proton is what? 1836 times of mass of electron. This is what? Me plus 1836 mass of proton. So finally you will get 1836 Me square by 1837 by Me. That means it is 1836 mass of electron by 1837, right? So which is approximately equals to what? Mass of electron, you can see. All right. So therefore what you will write? The binding energy of hydrogen atom divided by the binding energy of what? Positronium. Okay. EB for what? Hydrogen atom. Binding energy divided by binding energy for what? Positronium. Okay. So it is equals to what? For hydrogen atom, it is Me, electron bound to proton. And for the other one, it is what? Me by 2. So finally, Me and Lb will get cancelled and you will get it to be what? 2, right? So therefore, what you can write? For positronium, okay? For positronium, it is equals to what? If you see here, in this case, it is 1 by 2 of what? Binding energy for hydrogen atom, right? This is what you will have. Half of this one. This is what? Half of this means what? Half of minus 13.6. Okay. Or you can say just 13.6, right? So if you will do so, you will get it to be what? 13.6 by 2 electron volt. So you can write the correct option is option A. All right. So now let's see question number 2. Here it is said, consider the Bohr model of the hydrogen atom. Alpha, it is the fine structure constant. Then the velocity of the electron in its lowest orbit is what? So you are asked to consider the Bohr model of the hydrogen atom. Alpha, it is the fine structure constant. Okay. You will have to calculate the velocity of the electron in its lowest orbit. Okay. So for lowest orbit, you know, N is equals to 1 for hydrogen atom. So finally, velocity V, it is given by what? ZE square by 2h epsilon naught. Okay, N. So N is equals to 1 and Z is equals to 1. Okay, for hydrogen atom. So you will have E square by 2h epsilon naught. Okay, which can be written as V is equals to E square by 2h epsilon naught. This I'm considering to be equation 1. Now you see alpha, that is the fine structure constant. That is alpha. Alpha can be written as what? You have already seen the theory if you have studied. It is equals to E square by 2 epsilon naught AC. Okay. So from here, if you write E square by 2 epsilon naught H, it will be equals to what? Alpha C. This I'm taking to be equation 2. So from 1 and 2, you can write what? From 1 and 2, finally, you can write V is equals to what? Alpha C. Right? So the correct option is option C. That is the velocity in its lowest orbit is equals to alpha C. Clear? So now let's say question number 3. It is said if a proton were 10 times the ground state energy of the electron in a hydrogen atom would be what? So that's simple. Just you will have to calculate the ground state energy of the electron in hydrogen atom when the proton is what? 10 times. So I'm considering this mass of the proton to be MP prime. So MP prime is what? 10 times the mass of proton, right? So you can write MP prime is equals to what? 10 times the mass of proton means 10 times of 1836 ME, because this is the mass of proton, and you can write MP prime, it is equals to what? 18360 ME. And normally, you know, the energy is what? Minus 13.6 N square, okay? Into with, you can write what? Yeah, this is mu by ME. This is what it is. All right. So now we will calculate reduced mass, mu, okay? So mu is equals to what? It will be equals to ME into with 18360 ME divided by ME plus 18360 ME. So you can write it what? 18360 ME by 18361 ME. Okay. So when you will put this value here, then you can write En will be equals to what? Minus 13.6 into with. When you will divide, this is only this one. Okay. So when you will divide, you will get the value to be 0. There will be 49, then 455,367. Okay. ME. All right. This is what it is. So when you will write here, this 0.9999, this I'm writing 5. Okay. This is ME. And here you are having what? ME. So this ME and ME will get cancelled. And when you will multiply these two terms, minus 13.6 into with this term, then you will get it to be minus 13.59925593 electron volt. Okay. So when you see this value, minus 13.599 this, so this value it is greater than minus 13.6, right? Okay. So also you can see it is something is multiplied with this one. So the value will be what? More, right? The ground state energy of the electron of hydrogen atom would be more. So the correct option is option B. Clear? So now let's see the next question. So here it is said a sodium atom in the first excited state, okay, 3p state, has a lifetime 16 nanosecond for decaying to the ground state 3s state. Okay, the wavelength of the emitted photon is 589 nanometer. The corresponding line width of the transition in frequency unit is about what? So here it is said sodium atom, it is in the first excited 3p state, and the lifetime is given to you 16 nanosecond. So to decay to the ground state, okay, that is the 3s state, the wavelength emitted by the photon is 589. You can just write this is what? 3p state. Okay, this is the 3h state. Okay, when a sodium atom will what? When it will decay to the ground state, a photon will be emitted, right? And the wavelength of that photon is given to you 589 nanometer. So here it is said that you will have to find the corresponding line width of the transition. Okay. So here you see there will be energy difference. Okay. When there will be what? Transition from the excited state to the ground state, right? That means it is delta E. There will be a difference in time also, that is delta T. So you know you will use the uncertainty del E del T, it is equals to what? S less P no, right? So here you are asked to find the line width of the transition in frequency units, and frequency units you can write what? Delta f is equals to 1 by del t. You know the frequency is what? Inversely proportional to time. Okay, so here 1 by delta t. So lifetime it is given to you 16 nanosecond, right? 16 into with you write 10 to the power minus 9. Okay, converting it into seconds. So this will become hertz. Okay, so finally you can write it as what? 1 by 16 into 10 to the power 9. Clear? This is what you can write. And I'm writing this to be because you can see here unit is 6 or 7. So if I'm making it 10 to the power 7, you will have what? 100 by 16. So this will give you 6.25 into 10 to the power 7. Right? So approximate, you can write this to be 6.3 into 10 to the power 7 hertz. So this is what it is. So the answer will be what? The correct answer is question for this question, it's option C. So here what is it said, which functional form of potential best describes the interaction between a neutral atom and an ion at large distances, that is much larger than their diameter. You will have to say the functional form of potential which is best describing the interaction between what? Neutral atom and ion. So for this you can directly see what the potential energy U, if you can write a formula na, for infinite distance r from the nucleus, it is equals to the work done in removing the electron from r. Okay, so if we write U is equals to what? Minus 1 by 4 pi epsilon naught Z square by r square. Okay, you can denote U by V also. So you can see V is proportional to what? Minus 1 by r square, right? So the correct option is option A. So these questions are direct questions. You don't have to think so much about these questions. These are just theory-based questions. So now let's say question number 7. So here it is said, if a proton were 10 times lighter, then the ground state energy of the electron in a hydrogen atom would have been what? So just now, before some time, we have done one question where what? The proton was what? It was heavier. Okay, this time we will do for the lighter one. So when the proton is what? Lighter 10 times, that is mt prime will be what? Mass of mass of proton divided by 10. Okay, that is 1836 me, mass of electron divided by 10. That is 183.6 mass of electron. Okay, so reduced mass will be what? Reduced mass, it is me into with 183.6 me. When you will do the sum, you will get 184.6 me. Okay, me and me will get cancelled and you will have what? 183.6 by 184.6 me, which will give you 0.99456 mass of electron. So you can write the ground state energy, okay, when the proton is 10 times lighter, so it will be minus 13.6 into with, directly you can write 0.99456. Okay, this is what you can write. So here if you see me and me is getting cancelled, so you're having this. So you can write it to be minus 13.526 electron volt. So when you see this is greater than 13.6, yes or no? So it will be more. And directly you can see in the formula you are multiplying the reduced mass mu. So it will be what? Greater only. Okay. Clear? So now let's see the next question. If hydrogen atom is bombarded by energetic electrons, it will emit K alpha X-rays, beta rays, neutrons, none of the above. So first of all, when you will see the X-rays, so first of all, you know, hydrogen is the least energetic element. Okay. So even if you take the most energetic line of the hydrogen atom, okay, that means when electron will drop down from the second cell to the first, okay, then you will get that much energy only so that a ultraviolet photon will be released. So hydrogen atom, it cannot emit X-rays. So the first option is not correct. If you talk about beta and neutrons, this is a radioactive decay. Okay, so in this case, what happens? The entire process of emission takes place within the nucleus. Okay, in case of neutrons, it's a radioactive decay. One or more electrons are ejected from what? Nucleus. So this is also not possible, right? So the option is none of the above. Clear? Now let's see the next question. So here it is said a hydrogen atom in its ground state is collided with an electron of kinetic energy 13.377 electron volt. The maximum factor by which the radius of the atom would increase is. So you're having a hydrogen atom which is in its ground state. Okay, it is colliding with an electron whose kinetic energy is what? 13.377 electron volt. So you will have to say by which maximum factor okay, the radius of the atom would increase. Clear? Means the radius of the hydrogen atom would increase. So for this, if you see, for the energy, if we talk, we know the energy can be written as minus 13.6 by n squared electron volt. Okay. So for n is equals to 1 for the first orbit, if you consider E1 will be equals to what? Minus 13.6 electron volt. All right. Here you are having the electron's kinetic energy is what? 13.377. Okay. So if you write the energy difference, if you calculate the energy difference, so it will be equals to what? 13.6. Okay. This is what you will have. Minus, if you do, minus of what? 13.377. Okay. This is a minus sign. So you will write here what? Minus 13.6 plus 13.377. So you will get it to be minus 0.223. You can subtract and see. All right. This is what you will have. Clear. So now you see this energy is 13 minus 13.6 by n square. Okay. This energy difference is this one. So you can write minus 13. This must be equals to what? This. So if you write 13.6 by n square equals to what? Minus 0.223. We have calculated the energy difference. Okay. So that we can get the value of n square. So here if you see minus and minus will get cancelled. Okay. So from here you will get n square is equals to what? 13.6 by 0.223. So this will give you 61. And you know the radius Rn, it is equals to what? It is a naught n square. Okay, n square is what? 61. So if n square is 61, you know, it can be, we know 7 square is what? 49, 8 square is what? 64. 64 will exceed. So the chances for n equals to 7 is what? The probable chances is what? It must be 7. That means what? The maximum factor by which the radius of the atom can increase is by 49. We have done nothing. We have seen the energy formula. Okay. For the lowest orbit, we have calculated. Then we have calculated the energy difference. So, and we have taken this will be obviously equal. Okay. Energy difference of this must be equals to this. From there we have seen the value of n and then done. Just these are very simple. You will have to just use the basic. These are actually intermediate level concepts. So now let's see question number 10. Here you say the energy difference between 3p and 3s level in sodium is 2.1 electron volt. Spin orbit coupling splits the 3p level into emission lines, differing by 6 Armstrong. All right. So the splitting of the 3p level is approximately what? So you will have to tell what is the splitting of the 3p level. Okay. So here you see energy difference between 3p. So this is suppose the 3p level. And this is what? This is the 3s level. Okay. So the energy difference in sodium, it is say 2.1 electron volt. Spin orbit coupling, we know the sum of what? Spin angular momentum and orbital angular momentum. So due to spin orbit coupling, okay, spin orbit coupling, it is splitting the 3p level, okay, into 2 emission lines. So you can see here, this way it will be emitted into 2 lines, and we know how the splitting is done. Okay, it will be 2p 3 by 2, and this is what? 2p 1 by 2. This is how it is done, and this will be same. Okay, so you see the splitting of the 3p level is approximately what? And here it is said resulting in emission lines differing by how much? Their difference is given to you 6 Armstrong. The splitting of the 3p level will be approximately equals to what? So this is what you will have to calculate. Okay, so here if you see the transitions can be from what? From this level to this level. Okay, this is 3s 1 by 2. So when you will do C, it will be what? Delta J will be equals to 0. So this is allowed. And from here, if you see, this is lambda 2. So this is equals to what? If you do 3 by 2 minus 1 by 2. Okay. If you do and see, you will get it to be equals to 1. Means delta J is what? 1 comma 0. So these are the 2 transitions that will be allowed. Okay. Okay. Selection rules you can apply, and you have studied, I think so. And speed orbit comet, that is, you know, J is equals to what? L plus S. Yes or no? That means orbital angular momentum and the sum of what? Spin angular momentum. These things are very basic, you know. So now we will see what here you see you will have two energies. Okay, this energy is E1, this energy is E2. Okay, so E1 energy, this energy is for what? That for this transition. Okay, to this is what 3 2s 1 by 2, and it is equals to what? You know, E is equals to hc by lambda. From direct, this constant value will be what? 12400 divided by lambda 1. Okay, again next is what? 3 square means 3 2, it's not square, it's 3 2 p 3 by 2 to 3 2 s 1 by 2. So E2 will be equals to again 12400 divided by lambda 2. So you can write delta will be what? Delta E will be, it will be E2 minus E1. Okay, that is 1 by 12400. Okay, within the bracket 1 by lambda 2 minus 1 by lambda 1. That is equals to what? 12400. Okay, and here it is what? Lambda 2 lambda 1. That is lambda 1 minus lambda 2. We have already seen emission lines are differing by what? 6 Armstrong. So lambda 1 minus lambda 2 value is what? 6 Armstrong. So you are having here 12400 into with 6 Armstrong. It is just the basic way. Okay. Now if you see here, E is equals to hc by lambda. This is given. So lambda is equals to what? hc by E. Okay. So hc is 12400. Okay. This energy it is given to you. It is what? 2.1, right? So you can write this to be 2.1. Okay. From here you can write. So finally, if you see here, from this, you will have 12400 into with 6. Lambda 1 will be what? 12400. Here 2.1, again 12400, 2.1. So this two will get cancelled, right? When you will do this calculation, you will get here, when you will multiply this all, you will get this is 26.46 by 12400. And finally, you will have what? 0.002. So you can write 2 into with 10 to the power minus 3, all right? Which can be written as what? 2 milli electron volt. Okay. So the correct option is option B. So you can see the entire question was from this basic formula only. E is equals to AC by lambda. Clear? That's it. So if you see here, what was given to you, energy difference was given to you, right? 2.1. That is lambda. That is, it was given to you what? The energy was given to you. The energy difference between 3p and this value, E was given to you. Okay. And because of spin orbit coupling, the 3p level, it was splitted into two emission lines, and it was differing by 6 Armstrong. That is lambda 1 minus lambda 2. Clear? So you will have to just calculate the splitting of the 3p level. So the splitting of the 3p level is what? 2 into with 10 to the power minus 3. Clear? Now let's see the next question. Here it is said, which of the following excited state of hydrogen atom has the highest lifetime? 2p, 2s, 3s, and 3p. So here if you see 2s, you know 2s is what? It is a metastable state. We know metastable state are what? The states which are having what? Highest lifetime compared to what? Ordinary state. If you see 2p and 3p, these are ordinary states. And when you're talking about the 3s state, you see 3s state will what? It will what? It will have transition to 1s level, but it will not have directly, but it will have what? To 2p state. All right. And for 2p and 3p state, for normal state, the lifetime is 10 to the power minus 9 seconds. So when we are having any metastable state, then you know that it is having the highest lifetime compared to any other ordinary states. So your correct answer is what? Option B. Okay, correct. Clear? Because it is a metastable state, and we know metastable state has the highest lifetime compared to any ordinary state. Clear? So here is the question number 12. What it is said, which of the following statement is true for the energies of the terms of the carbon atom in the ground state electronic configuration 1s to 2s to 2p2? So you're having four statements. You will say which one is correct. Okay. For the carbon atom in the ground state, electronic configuration is given. So you will take what? P square. Okay. So P2. So if you see here, there will be what? 2 electrons. L1 will be equals to what? 1. and L2 is also equals to 1 because it is p cell. We know S, P, D, F. Okay, so it is 0, 1, 2, 3. Okay, and if you see the spin, S1 is also equals to half, S2 is also equals to half. Okay, for both the electrons. So if you see here, you can write capital L is equals to what? L1 plus L2 to L1 minus L2. Okay, that is what? 1 plus 1 to 1 minus 1. So it is 2 to 1, so it is 2, 1, 0. Similarly, if you calculate S, you will have what? S1 plus S2 to S1 minus S2. So half plus half is what? 1, half minus half is what? 0. Clear? So now if you see the multiplicity you will write multiplicity. It is equals to what? 2s plus 1. Okay, so for s is equals to 1, s is equals to 0. For s equals to 1, it's 3. For s equals to 0, it is what? 1. Okay, so what will be the terms here? If you see L is equals to what? 0, 1, 2. So it is what? S, P, D. Right? Again, you will have what? S, P, D, because you are having what? 3 and 1. So this is for 3, 3, 3, and this is what? 1, 1, 1. Okay, so which will be allowed and which will be not allowed? Which will, this is what? Not allowed, because you will take this one. Okay, again alternate, this not allowed, this allowed. Again what? This not allowed, this allowed. So you will have the terms to be 3p, 1s and 1d. All right, these things I think you know because you have done in your this intermediate levels. Okay, so these are the spectroscopy terms. Okay, now you will see when you will have what? Hume's law you will apply when you will have the all the multiplicity will first you will see the what? Highest multiplicity will have what? Lowest value. Okay, so here if you see here 3p, it is having the highest multiplicity, so it will have a what? The lowest value. Means what? S is what? Greater, then it will have what? The value will be what? The lowest. Okay, so this will come first. Next you see when you will have the same multiplicity. So here if you see the multiplicity is what? Equal, then you will say what? With highest L, it will lie the lowest. So highest L is which one? D. Okay, L is equals to what? For D it's 2. So then it will come 1D and then it will come 1S. Clear? So the correct option is option A. Done? So now let's see question number 13. Here it is said the hydrogen molecule has a reduced mass. M is equals to 8.35 into 10 to the power minus 28. Okay. Equilibrium integral frequency is what? R equals to this one. So you will have to calculate the rotational energy in terms of the rotational quantum number J into J plus 1. So this is just direct. We are having the reduced mass and the internuclear resistance. We know the formula for rotational energy is what? E rotational is what? H cut square by 2I. Okay. Here J into J plus 1. So from the formula, if you see J into J plus 1 is only in option C and option B. So out of this two, we will have one option. So we will have to calculate the value of this term. Okay. H cut square by 2I. So if you know I, it is what? Mu R square. Mu is what? The reduced mass 8.35 into it 10 to the power minus 28. And here you are having what? This 0.742 into it 10 to the power minus 10 whole square. Okay. So when you will do this calculation, 8.35 into with the square of this, you will get 4.597. And this will give you what? 10 to the power minus 48. Okay. Unit will be as it is. So finally, you will have to calculate what? H cut square by 2I, right? H cut square. So it is what? 1.05 into 10 to the power minus 34. Okay. Divided by, this is whole square. And here you're having 2 into it, 4.597 into it. What you will write here? 10 to the power minus 48. So this is giving you what? 1.05. Its whole square will be 1.1025. Okay. Divided by, when you will multiply this two term, you will have it's 9.194. Okay. And this is what? 10 to the power 68 minus 10 to the power minus 48 it is. Okay. So you will get 10 to the power minus 20. When you will divide this two, you will get to be equals to what? You will get 0.119951621. I'm writing directly the values. You can do and see. Okay. So I will make it 10 to the power minus 21. And this will give me what? The pointer will become this side, so I can write 1.12. Okay, this is what I can write. Clear? This is what you will have. Sorry, it's 1.21. Okay. All right. So you can just directly write. Now you will have to convert. You are having it to be equals to what? 1.21 into 10 to the power minus 21. Okay. This is there. Okay. So you will have to convert it into what? Electron volts. So you will multiply by what? 1 by 1.6 into 10 to the power minus 19, right? Electron volt. And this is J into J plus 1. So when you will do this entire calculation, here you will have what? 10 to the power minus 3, right? And this you will give you 7.57. J into J plus 1. So you can write it to be equals to what? This entire term, if you would convert it, this one, 7.57, this is electron volt, okay? 7.57 into 10 to the power minus 3. So you will convert milli electron volt because the unit is that. So you will get 7 into it approximately, okay? 7.57 will give you approximate value. So it is J into J plus 1. Directly you can write 7 J into J plus 1. Clear? So the correct option is option C. All right. So this is how you can calculate. Just direct formula based questions are there, so you don't have to worry so much. All right. Just if you remember the formula, then you can do. So here it is the constant of an atom of finite mass is what? Alpha R infinity. Okay. That means Rydberg constant I'm taking Rm. For a atom of finite mass, it is given to us to be alpha R infinity. R infinity, it is the Rydberg constant to an infinite nuclear mass. This is for infinite nuclear mass, R infinity, the Rydberg constant, and this is for what? Finite. So I'm considering this to be Rm. This is for finite, okay? And R infinity is for infinity. So you will have to calculate what you are asked to do here. You are asked that if the Rydberg constant of an atom of finite mass is this, and R infinity is the Rydberg constant to an infinite nuclear mass, you will have to calculate the ratio of electronic to nuclear mass of the atom. All right, just you will have to calculate the what? Ratio of electronic mass and nuclear mass. All right. What you are asked to calculate electronic to nuclear mass means what? mc by capital M. This is mass of the central atom. Okay. So for this, you will have the direct formula from the Rydberg constant. Rm it is equals to what? R infinity 1 plus this is what? Mass of central atom divided by capital M. So Rm is given to you alpha R infinity equals to what? R infinity 1 plus mc by m. R infinity get cancelled. So 1 by alpha is equals to what? Right? So it is equals to what? It will be 1 plus mc by m. So from here, if you see here, what you will write 1 by alpha minus 1, it is equals to what? mc by m. This is the ratio that you are asked to find. So when you will do so, you will take this to be alpha. This is 1 minus alpha mc by capital M. So you are getting the ratio to be what? 1 minus alpha by alpha. So the correct option is option A. Clear? Very easy and very simple. Now, here it is said, what is the difference between the maximum and minimum energy eigenvalue? Eigenvalues means energy values, okay? Of the two electrons whose Hamiltonian H is equals to JS1 dot S2, where S1 and S2 are the corresponding spin angular momentum operators. So you are asked to calculate the difference between the maximum and the minimum eigenvalues of the system, that is energy values, okay? For what? Two electrons whose Hamiltonian is given to you. So this is also a very direct formula. You are asked to calculate just the difference in the energy values. Clear? For two electrons whose Hamiltonian is given to you, S1 and S2, these are representing the spin angular momentum. So what is given to you? H is equals to JS1 dot S2, right? So if you see here, you know S is equals to what? S1 plus S2. All right. If you do the squaring, then you can write, if you do this to be S square is equals to what? S1 square plus S2 square plus 2 S1 S2. Okay, from here you can write S1 S2, it is equals to what? S square minus S1 square minus S2 square divided by what? 2. Right? This is what you will write. So you can write from here. Okay, what you will write? H is equals to J. Okay, H is equals to what? J. All right, this is what? S into with S plus 1 minus S1 into with S1 plus S1. This is minus S2 into with S2 plus 1. This is a 1, okay. All right, and this entire term divided by 2, okay. Ignoring the H cut because it is equals to 1. Now you see, 2 electrons are there. So S1 is equals to what? Half. S2 is equals to what? Half. So you can calculate S, same S1 plus S2 to S1 minus S2. So half plus half will give you what? 1. Half minus half will give you what? 0. All right. So now for S is equals to 1, you will calculate the value. Okay. Then you will calculate for S is equals to 0. For S equals to 1, that is the first state. S equals to 0 is the ground state. So if you calculate EF is equals to J. All right. Here you see, this is S is equals to what? 1. So it's 1, 1 plus 1 is what? This is 2. All right. Minus, this will give you what? S1 is what? 1 by 2. So 1 by 2 plus 1 is what? You will get it to be what? If you see here, 1 by 2 into with what? 1 by 2 plus 1. So it is becoming 3 by 4, right? Minus, again, you will get here what? 3 by 4. All right. This entire term divided by 2. So from here, if you see, when you will do the calculation, it will be what? 8 minus 3, right? 8 minus 6, sorry, divided by 4 by 2. So it will give you what? 2 by 4 by 4. So ultimately you will get this to be equals to what? J h cut square by 4. Yes or no? 2 and 2 will get cancelled. That way, again, if you see for S equals to 0, you will have EF is equals to what? Directly only these two terms will be there. Minus 3 by 4 minus 3 by 4. Right? And this is what? 2. Clear? This is what you will have. So if you'll get here, it will give you what? Minus 6 by 4 by 2. And this will give you what? 2 I will cancel this 3 times. So it is minus 3 by 4 and J. All right. This is what we will have. Now you are asked to calculate the difference between the maximum and the minimum. Maximum and the minimum means what? Maximum is EF, minimum is AG. So when you will do so, you will get what? J h cut square by 4 minus will become plus. It will be what? 3 by 4 J. Okay. So when you will see this h cut square, I'm ignoring. Okay. Here by mistake I have written. So it will give you what? 4J by J, that is ultimately equals to what? J. Or you can get J h cut square. H cut is equals to what? 1. So it will be 1. So the correct option is option D. Clear? Just you will see the calculation. We have done nothing. We have seen the value of S, S1, S2, and we have just used the Hamiltonian. Now let's see the last question. Okay. So here it is said, consider a hypothetical world. Okay, this is not world, this is world. In which the electron has spin 3 by 2 instead of 1 by 2. You are having a hypothetical world where electron is having spin 3 by 2 instead of 1 by 2. So you will have to calculate, okay, the electronic configuration for an element Z is equals to 5. So for this spin, okay, you will have to see the electronic configuration for an element whose atomic number is given to you 5. So for this, you will see what? The degeneracy level of J. Yes or no? The degeneracy level of J. So you know degeneration is what? 2J plus 1, right? So here you are having the value of what? Spin S, right? So you see for S orbit, directly you can write for S orbit. Okay, you will write D is equals to what? 2S plus 1. Yes or no? This is what we are saying from S orbit only, na, the spin of the electron. So it is 2 is equals to 2S plus 1. So it is 2 into S is what? 3 by 2 plus 1. So you're getting the degeneracy to be equals to 4. So if the degeneracy is equals to 4, then directly it is the configuration will be what? 1s4 and 2s1, because this is what? This will give 4 2. Wherever you're having the degeneracy 4, these are the 2. So you are see if you see here, this is 4, 6, 7. This is not done. This is not done. So you will have only option A. So the correct option is option A. Clear? So these are very direct questions. I think this will help you for your Just examinations. So that's all in this video. Thank you so much. Have a good day.